Hi, welcome back to Moose in Chemistry. This lesson's on colligative properties. This is our first lesson, and we're going to talk, first of all, about colligative properties. What are colligative properties? Colligative properties depend upon the concentration of the particles in a solution and not their identity. Okay, so let's look at a problem, and let's see what that really means. Well, let's look at this problem. If I add 45 grams of sodium chloride to 500 grams of water, what will be the melting and boiling points of the solution? So when you add colligative properties, or when you involve colligative properties in a solution, you can either raise the boiling point, or lower the freezing point of a solution. So we have two formulas that we're going to look at here. First of all, we're going to look at the formula delta TF, that's for freezing, equals IKFM. And the other one over here is delta TB equals IKBM. Okay, so now, a couple things. This is the freezing point constant. This is the boiling point constant. And each solution has its own freezing point constant and boiling point constant. This is molality. These arrows are pointing to molality, not molarity. Remember that molality is equal to moles of solute over mass of solvent in kilograms. Okay? Quite different from molarity, which is moles of solute over liters of solution. Okay, so we need to know what Kf is, and we need to know what Kb is. So let's go ahead and erase a couple things here. So I'm going to erase these arrows here, because we've explained to you what those things are. All right, so now, like I said, each solution has its own unique Kb and Kf. So we're doing this with water, because it tells us that we have water. Okay, so now, the Kf value for water, H2O, the hydrogen monoxide, is equal to negative 1.86 degree C over little m. And the Kb, which is the boiling point for water, colligative property value, or constant if you want to call it, it's going to be 0.51 degree C over little m. Okay, now, let's go ahead and set up our problem. Oh, look, we have 45 grams, and we need moles. So we have to turn grams into moles. So we have to do that first. So we go 45 grams of NaCl times 1 mole of NaCl. And we learned this way back when we were doing stoichiometry, divided by the molar mass of NaCl. Now the molar mass of NaCl, remember, is 58.44 grams. So that's going to give us an answer of 0.77 moles of NaCl. Okay, where did the 58.44 grams come from? All right, well, let's look over here real quickly. We have NaCl, so we have one sodium atom, and we have one chlorine atom. So that's 22.99, which is the molar mass, and this is 35.45. When we multiply those together, we get 58.44 grams per mole of NaCl. So this tells us where that number comes from. So I'm going to go ahead and erase that real quickly, because we really don't need that anymore. We just need this value here. All right, so let's erase that. So we've erased that. So what we need to do now is we need to determine what our little m value is. We have our Kf value. We have our Kb value. But now we need to know what is our m value. And that's molality, before we can even solve this problem. So let's go ahead and calculate what little m is. So little m is going to equal to, remember, it's moles of solute over mass of solvent. All right, so we know we have 0.77. Oh, look, we have 500 grams, but it's got to be in kilograms. So before we can put the bottom number down, we have to change 500 grams into kilograms. So if we look up here at the top right-hand corner, we go 500 grams into kilograms, put a 500 here, and move the decimal place 3 points. And that gave us 0.500 of a kilogram. So we're going to put that right here. Okay, and we got that in moles. So now our molal is going to equal 1.54. 54 little m. Okay, now we have our m value. Now we have our kf value and our kb value. Now we can solve the problem. So let's go ahead and get solving here, okay? All right, so let's get rid of those arrows real quickly. And now we get ready to let's do the freezing point depression first. So we go delta TF equals, oh look, that I. This also has an I. That's called the Van Hoff factor. And it only works with ionic compounds. So in other words, when a compound like an ion, like sodium chloride gets into H2O, it dissolves into sodium ions and chlorine ions, right? So that means that there's one sodium ion and one chlorine ion. Okay, so if that's true, that means when this thing dissolves, when NaCl breaks apart, it breaks apart into Na plus Cl negative. And this is what we're talking about for our I factor. So there are two ions. So I is going to equal to 2. Okay, I'm going to let you look at that for a moment before I clear that drawing and erase it. Okay, so let's go ahead and erase that real quickly because we do need the space. Okay, so now all we have to do now is plug in the number 2 for our I. Our Kf value is negative 1.86 degrees C over M. Okay, so then we close that right there. And then we, of course, we put our M value, which we found out to be 0.154. Okay, our M's cancel out. And we multiply this through. We get negative 5.72 degrees C. Okay, so then you add that to 0, and that's the freezing point depression. Now we add that to see, find the new freezing point, so you add it to 0, negative 5.72 degrees C, and that gives me a new freezing point of negative 5.72 degrees C. All right, let's do the boiling point elevation. Delta TB equals IKBM. Okay, again, our I value is 2. This time it's 0.51 degrees C over M times our M value, which we got from right here. Okay, so that cancels out, and that gives us a temperature about 1.54 degrees C. So we want to know what the boiling point elevation is. We simply add that to 100 degrees C plus 1.54 degrees C. So our new boiling point is 101.54 degrees C. And these are our answers. You guys have a snarling day, and we'll see you back at Moose and Chemistry.